Here we are in part 3 of aquatic and terrestrial pollution, and off we go. I'm going to talk about solid waste disposal, not only landfills and such, but also the reduction of waste. So I'm going to kind of combine these two topics. So first of all, there are really 3 ways that we can dispose of solid waste. We can, put solid waste into landfills. We can burn it or do incineration, and we can recycle. And let's look at the first one, which is a landfill. This is the most commonly used method of disposal. So basically, if you throw your trash away, likely it's going to go into a landfill. The first thing that they put down when they actually start creating a landfill is put down an impervious layer on the bottom. So, plastic or clay liner. Then they'll put some gravel down and put some collection pipes to collect the leachate, or really the liquid that will ultimately percolate down through the landfill. And so we want to be able to collect that, because that is filled with all kinds of not good stuff that we want to collect and then treat before we let the water out into surface waters. Basically what they do, you can see in this picture, is they take a bunch of trash, put it into what we call a cell, or just like a block for the day, and then when the day is over, they compact it and then put a very thin layer of soil over the cell, and then the next day they continue on with another cell. And they do this until basically the landfill is at capacity, and they cap it. And we'll talk about that in a second, what you do with the landfill once it's done. But really importantly is that as trash is decomposing, right, it's not exposed to oxygen, and so therefore as it's decomposing, it is creating methane. And so we actually put a pipe system into place, so that way we can collect the methane gas, and we can either burn it off directly, or we can burn it to create energy. So, right, we're burning the methane to make steam, to turn a turbine, you know the drill. So that's really important to be able to collect that methane, because if not, you end up with these methane bubbles in your landfill, and you could imagine what may happen with exploding garbage or something like that. Gross. Anyway, like I said, once we have hit capacity, they put this impervious or vegetated, they put an impervious surface over the top of the landfill, and then they vegetate that. So they put a layer of soil over it and then seed it, and you end up basically with a big grassy mound. Here's another picture, an anatomy of a landfill. If you guys want to pause and take a look at this diagram, I really like this diagram. You can see that bottom layer there, and kind of see the way that they start a landfill, build the blocks, collect that methane again, right? And collect the leachate and store them. Treat them, store them, and all that good stuff. Like I said, once the landfill is full and they want to close the landfill, they put an impervious surface over it. So again, clay, a plastic liner with some soil, and then they vegetate it. Usually it's with grass. So you can see this like big grassy bump here with the pipes sticking out. Those are the methane collection pipes, if you look closely. But, you're left with this like big open, vegetated, but not with tree, right? With zero tree cover, which leaves you space for solar panels, which, big open space to collect solar energy. Great. You could make a park out of it. So for example, in Stanford, there's Schofield Town Park and Yard. And then in Norwalk, there's Oyster Shell Park by the mall. Another thing that they've done with landfills is forest them. So actually try and get tree cover on the landfill. It's a little more difficult, but it has been done successfully. There are issues with landfills, though, obviously, like we had talked about already. There's this methane gas that's produced when you have the decomposition of that solid waste. Obviously, a landfill takes up a lot of space. And then things that should be, recycled or not thrown in a landfill are disposed of in the trash stream, and so you end up with them in landfills. It's impossible to pick them all out, So there's plenty of batteries and liquid waste such as paint, hazardous waste like pesticides and cleaning products in your home, prescription drugs, tires. Tires are a huge problem in landfills because they can catch fire and they trap bubbles of methane because there's like space, right? And then also anything that can collect water can always increase mosquito populations, and so that increases disease vector, right? So, landfills have their issues. And so what else can we do to, with our solid waste? Well, we could burn it. And so we talked about waste to energy before, and not all incineration is actually made into energy. Some of it's just burned and then the ashes disposed of, usually in a landfill. But that solid waste that we burn, we actually reduce its volume by 90%. And so, that is a significant reduction in volume. The heat that we do generate from burning can be made to generate energy. So that's, exciting. And the problem, though, is that when you do burn trash, you end up with a lot of air pollutants. So particulate matter, heavy metals like lead and mercury end up in in the atmosphere and then ultimately down on the ground. So to reduce solid waste altogether, we can take it out of the trash stream by recycling. And so some products are recycled into the same kind of products. So aluminum cans and paper are converted back into new aluminum cans and paper. This is usually pretty inexpensive when it comes to that. But when you start converting other products into other products from what they were originally, that can get a little costly and kind of energy inefficient. And so plastics are an example of being converted into something different and being pretty cost inefficient. Not to say we shouldn't do it, because, it has a lot of benefits, right? We're reducing our resource use and pollution. Like I said before, right, it can cost less than raw products, but also it could be costly, both in money and energy, depending on what product we're talking about. It's also heavily consumer dependent. So you as a consumer need to recycle. And so there are all kinds of laws that can help incentivize us, like the bottle deposit. In Connecticut, it's increasing to 10 cents, so that's exciting. Maybe our recycling rates will go up. Another way to reduce our solid waste is by recycling our e-waste or our electronic waste. And so as we get more and more technologically advanced, right, we have a massive solid waste problem in terms of electronic waste. Most of it will end up in the landfill, but the problem is that there's a lot of toxic materials in e-waste. And so, like we had said before, right, it can, as it's sitting in the landfill, it can percolate down through the landfill, in the leachate, and down into the groundwater and contaminate drinking water. So, we really want to get it out of that landfill. Also, it has really high quality plastics that we can use again and valuable metals. So instead of mining, right, we can actually recycle the metals that are in the e-waste. The problem is, right, is that it can be costly and it uses a lot of chemicals. So there could be pollution from the recycling itself. Composting is yet another way we can reduce our waste, right? Really, food waste is a huge problem and it creates a lot of methane. And so by taking the food waste out of the waste stream, we create a lot of space and reduce that decomposition, which, is good. And we can put all kinds of stuff in composting, food scraps and yard waste, like clippings and such. And then, on a more industrial scale, you have like the sewage sludge, which we'll talk about in a bit. And then also manure, right? So we're looking at, biological waste, which you should not do in your residential compost, but municipal compost is actually, pretty efficient and can compost way more than you can in your backyard. So just because of the equipment that they have and just the amount that they get ends up making the pile a lot hotter and can kind of kill off bacteria more. Ultimately, if we're working with, compost in terms of industrial compost, you want it to cure for a while before you actually use it. But ultimately, you can use it in your garden, right? In your yard. All of those, yeah, it's great composting. But also, it could, sorry, I got kids in the back. But it could also be stinky. So, just like anything else, whether it's landfills, incineration, recycling, composting, right? All of these things you have to think of in terms of like cost benefit. So another kind of waste, right, is actually sewage waste. And we really do need to think about this because, these people and animals, well, mostly people, that we're going to be talking about people waste, but this is really important. This technology can reduce disease and is really important. So we're talking about sanitation here. So let's talk about sewage treatment. The first kind we're going to talk about is just a septic system, which is a very, very simple system. Basically, there is a tank that holds any kind of waste coming from your house. So anything that goes down a drain, yes, from your toilet, but also from your shower, your sink, your washing machine, your dishwasher, right? All of those things go into your septic tank and just kind of sit there. And because there's no flow, the solids will ultimately settle at the bottom, and the bacteria that is in there can actually digest and reduce those solids. And so every 3 to 5 years, someone comes out and actually pumps out those solids. But, for a long period of time, you can keep having inputs without any problems. The excess fluid actually goes into a leachate field, and so basically the liquid that's sitting on top will slowly leach into the ground surrounding it. And so, the soil can help purify that water before it ultimately gets into the groundwater. Some pollutants, though, definitely don't decompose. And so if you're not careful, it can contaminate groundwater, especially, if there's many septic tanks in the area. So for example, Long Island, their entire aquifer, their unconfined aquifer is contaminated by septic systems. So the water from Long Island is actually coming from a confined aquifer below the contaminated aquifer. So, septic can be an issue, but it's very common in more rural areas. The municipal sewer So this is what most places have in the city, right? And all of the waste flows by gravity to the sewage treatment plant, and then it goes through a series of steps. So the first step being a preliminary treatment. So basically there's this screen, like a bar screen, or if you could imagine like just a set of bars running up and down, and anything that's too big just won't flow through it. And so that takes all of the big things out of the water. So the next part, I don't want to say second because it's called primary treatment. So the next part where the water flows way, way down. And as the water slows down, the solids will settle out. And the more like floaty stuff, that's a technical term, floaty stuff, right? Oils and some food particles will float to the top and they skim that off. The solids settle to the bottom and then the liquid moves on into secondary treatment. So secondary treatment is a biological treatment. It's one of the most important steps in sewage treatment because really what it's doing is getting that nitrogen out of the water. You have ammonia from urine that's in the water, and so through the nitrification process using the bacteria that's in that sewage water, actually converts the ammonia from ammonia to nitrite to nitrate, and that is done by adding oxygen into the system. Once that conversion has happened, it then goes into a denitrification or an anaerobic area where there's no oxygen added to the system. And without the oxygen in the system, the bacteria still need oxygen, so they'll pull the oxygen off of the nitrate. And that leaves us with diatomic nitrogen. It just goes poof off into the atmosphere, along with 78% of our atmosphere, right, is made of nitrogen. And so that is, it really reduces the nitrogen by quite a bit. If we don't do this, the effluent that comes out in the end would be way high in nitrogen, and we could have some serious issues in the surface water where it's disposed, like, like algal blooms and whatnot. So once this denitrification process has happened, it goes into final clarification, so another settling tank, just like in the primary settling, but now the water has been kind of treated and the nitrogen is out and it doesn't have as many solids. And that final tank, you have the solids that settle to the bottom. We call that activated sludge, which we'll talk about in a little bit. But after final clarification, that water is fairly clear, and then it gets disinfected, whether it be with UV or chlorine, depending on what that plant uses. So the water can then get treated through tertiary treatment. It's really not widely used, but it can reduce other pollutants in the system, like phosphorus, for example. But it's really not used very much. Usually it just does the straight through primary and secondary treatment and then out into the surface water. So the solids get disposed of, so especially from that primary treatment, but the final clarifier, the activated sludge, some of it gets disposed of also, but then some of it gets put back into the system. And that's really important because it has a lot of bacteria that we need for that secondary treatment process. And so how do we dispose of it? Usually those solids have a lot of water content, so we add a polymer that dewaters the solids. We press it out, and then we can use it as fertilizer, mulch, whatever it may be. So, the solids get recycled either way. Here is a really lovely diagram of sewage. Sorry, the words wouldn't come out for some reason. All right, so I like this diagram just to kind of give you an idea about how the process goes. You know me, I like my diagrams. The disinfectant they're showing there is chlorine. Here in Stanford, we use UV light. But again, it all depends on what the plant uses. Where are they? Where does their effluent go? Their effluent is that, is what's coming out of the plant in the end. And so if it goes into a river, sometimes they'll use chlorine. But, if it's going directly into like a surface water like Long Island Sound, we do use UV. So take a look at this diagram. It's a good one.